Uh, okay, this is week number 4 lecture series, and today we will discuss all the lectures what you taught on the lecture series week number 4. Okay, I am sharing my screen. I think my screen is visible to you all. Is it visible?
Yes, it is.
Yeah. Okay. Myself Subrata Kumar Maiti. Uh, this is the class on the subject entitled hydrogen energy, that is production, storage, transportation, and safety. This is week 4 lecture series, live lecture series. In this lecture series, we will discuss we will discuss the different process, the different method associated with the hydrogen purification. This is maybe pressure swing adsorption process, membrane based separation process, and different chemical based separation process, as well as next we will see that the what are the different other different processes that can allow to produce hydrogen, just like water splitting process. Water splitting process also divided into two categories, like thermo-neutral chemical process, and another one is the electrolysis process. Okay, and there are different categories like membrane based water electrolysis and solid oxide or metal oxide based separator that will help to produce hydrogen from the water. Okay, first I am coming to the first purification process. Okay, there are the different method associated for the hydrogen production, like you have already studied that. Okay, you have already studied, that is the second. Okay, you have studied that natural gas reforming, that is the steam methane reforming process. Okay, next is the methanol reforming process. Okay, take just give me pointer, laser pointer. A natural gas pointer, methanol reforming process, coal gasification process, biomass gasification process, coke oven gasification process, coke oven gas. These are the different methods by which hydrogen can be produced. Okay, already you have studied the process. Already you have studied the process. This the table indicate that in which process what is the efficiency of producing hydrogen, in which process what is the better producing of hydrogen. In the first process, that is the steam methane reforming process. This is the natural gas reforming process. This is the most economical and beneficial process that is associated with the industry, and it has a lower hydrogen production cost. The efficiency is also very high. The hydrogen production percentage is also very high. 70 to 75% hydrogen can be recovered by using this natural gas reforming process. Then according to then as follows, methanol reforming process. Okay, as methanol reforming process, though it is a very high percentage of hydrogen recovery process, but it is not still used in the higher level or mass productions of the hydrogen. Next is the coal gasification process, 25 to 35 percentage, biomass gasification process, and coke oven gas. Okay, hydrogen is produced, and along with the other different gases is also produced, like sulfur is coming, and nitrogen gas, and water vapor, and carbon monoxide, and carbon dioxide, and some undissociated form of natural gas like CH4, methane is also coming in the outlet. Okay, that is, you may say that it is a mixture of gas is coming in the outlet or in the outlet feed. Okay, from this hydrogen should be separated, or pure hydrogen should be separated. Why hydrogen should be separated? Because for the specific application, the clean and high purity of the hydrogen should be useful. Okay, a different purification process. There are four basic hydrogen purifications method, like adsorption based process, hydrogen purification process. In the adsorption based process, that means a gas mixture will passes through one chamber, and some of the other gas except hydrogen, that is the impure gas, will be absorbed by the chemicals. This is the adsorption based separation process, first process. The membrane based separation process, that means that membrane will allow only hydrogen from the gas mixture, okay, in such a way that membrane should have high selectivity properties. On the basis of the high selectivity, this membrane can allow only hydrogen gas, okay, and other gas will be separated, and hydrogen can be, you can get the pure hydrogen through the membrane. And next is the absorption process, absorption based process. First one is the adsorption based process, and third one is the absorption. Adsorption means, and absorption. Adsorption means like like uh, adsorption means, suppose some silica gel, okay, some sort of chemicals, which is some gas molecules or some impure gas will be adsorbed, adhere. Adhere means, you can know that some gas molecule will be adhering to the surface. This is the adsorption process. And absorption process, it means that the it will absorb, like silica gel in your laptop bag. This will absorb the water molecules or water vapor, such that your laptop will stay, laptop will stay in weight free conditions or water vapor free or water free conditions. Okay, and fourth one is the cryogenic separations. That means cryogenic means, obviously cryogenic means low temperature process. According to the low temperature process, I mean melting point. Okay, the different gas phase will be liquefied. As we go on decrease the temperature, the gas will be converted into the liquid phase, and in such a way different gases, the different uh, liquefaction temperature. Okay, different liquefaction temperature, we can separate different gas. Okay, this is the four different methods for hydrogen purification process. First, the important process is the pressure swing adsorption process. This is the most suitable and appropriate and high efficiency process that is useful for the industry for the large scale operations. Okay, for the pressure swing absorption process, already you have studied that in the SMR reaction. Okay, after high temperature water gas shift reaction, the pressure swing adsorption process is may install can be installed. Okay, and in the other way, you can also install one path such that hydrogen gas, you can get the pure hydrogen gas like steam methane reforming process, high temperature water gas shift reactions, low temperature water gas shift reactions, then the removal of the carbon dioxide. Okay, it's maybe by the using of methanol. Okay, next is the methanator reactions. Okay, this step is very important. This pressure swing absorption process, it can be installed after high temperature water gas shift reaction. High temperature water gas shift reaction. Do you know the high temperature water gas shift reaction? What is high temperature water gas shift reaction? In which process the carbon monoxide is converted to the carbon dioxide with the help of the steam. Okay, and after producing carbon dioxide in pressure swing absorption process, carbon dioxide will be adsorbed to the chemicals. Okay, chemical surface, upper surface of the chemical. Okay, by the using of the higher pressure. Okay, that is called pressure swing adsorption process. Okay, you already studied, but here in details we will study the pressure swing adsorption process. Okay, what is the principle of the pressure swing adsorption process? In the pressure swing adsorption process, pressure swing means high pressure. High pressure, due to the high pressure, the different gas molecules will be adsorbed into the different chemicals. Okay, different chemicals, but hydrogen will not adsorb by the chemical, such that the hydrogen will, you can get the pure hydrogen. Okay, and this chemical can be regenerated by lowering down the pressure. At higher pressure, the different gases, other gases like carbon monoxide, carbon dioxide, water, H2O, can be adsorbed by the chemical at higher pressure, and hydrogen will be coming out as separately. Okay, and next, if we, for the regenerations of the chemicals, you have to go through the lower pressure, you have to make the lower pressure. Okay, give me 1 minute. Okay. Hmm. Okay, This is the process. This is the process. Different gas molecules, including hydrogen, carbon dioxide, CH4, hydrogen, carbon monoxide, and water vapor. Water vapor. This is the gas, a mixture of the gas. You have to separate hydrogen. How you will separate hydrogen? You have to use the pressure swing adsorption process. Okay. There are simple two steps. First one is the adsorption process, and next one is the desorption process. In adsorption process, in adsorption process, pressure will be high pressure at higher pressure. Okay, at higher pressure. And desorption process, pressure is the higher pressure. This is the high pressure. Okay, and desorption process, the pressure will be lower pressure. Okay, lower pressure. Okay, desorption process. Just you remember these things. Adsorptions will occur at the higher pressure and desorptions will occur at the lower pressure. Okay, and you will also remember that except hydrogen, all other impurities like carbon dioxide, carbon monoxide, H2, SO2, or CH3, or steam H2O will be adsorbed by different chemicals. And this higher pressure and lower pressure, I told you that what is the maximum level of the pressure, what is the lower pressure, these all the conditions, the designing pressure, higher pressure, designing lower pressure, and the temperature will be dependent on the chemical, the properties of the chemicals, and the different chemicals. Okay, and the different chemical properties like surface properties. Okay, porosity of the chemicals. Okay, and what is the pore size, micropore, mesopore, macropore. These are the properties which can control the adsorption process of different gas. Just this is the process. There are four steps. There are four steps. Pressure swing absorption process. First one is the adsorption step. Adsorptions. Okay, adsorptions always will occur at the surface. Suppose this is one uh, chemicals. This is one chemicals. It's maybe silica. It's maybe uh, MOF, metal organic framework. Okay, this has a very micropore on the surface. Micropore on the surface. Okay, if you study the MOF, it has a very high surface area. This is generally micropore. Okay, and in this pore, the different gas will be adsorbed. Adsorbed. Okay, okay. This is the adsorption process at higher pressure. Why it is higher pressure? Because at higher pressure there are the micropores. This gas will interrupt into the pore, into its porosity, into its pore. Okay, this is the at higher pressure. Obviously, during the when we will release the pressure, the gas will coming out. Okay, this is the simple concept. Okay, and for the industrial applications, next step is the counter current blowdown depressurization steps. Depressurization steps mean just lowering down the pressure or reducing the pressure. Okay. Third one is the counter current purge. In counter current purge, the small amount of the hydrogen is purged. Okay, such that all the contamination and all the remaining hydrogen some sort of hydrogen will also be entrapped into the pore. This hydrogen will come when this process will be run. Number 3 process. Next is the pressurization step, recycled, purified gas used. Next, up to this 3 process, 2 and 3 process, this is the pressure reduced, pressure was at lower pressure, but for creating higher pressure, for generating higher pressure, you have to push the fresh hydrogen at a higher pressure such that this column will get ready for the first step. Okay, get ready for the first steps means it will be again at higher pressure conditions. Okay, and additional steps also can be installed or also can be implemented for better way of purification. Are you getting how the pressure swing adsorption process operates? Hello, hello, hello. Are you getting me? Am I audible? Okay, just wait. Am I audible? Okay, screen is visible, na? Okay. Pressure swing, pressure equalizations and provided purge. This is the process for maintaining the intermediate pressure. Okay, the high pressure chamber, high pressure reactor, not reactor. This is the chamber filled with different chemical, which will absorb different gases. Okay, this is the feed high pressure, and this is the lower pressure chamber, such that the due to this pressure difference, due to this pressure difference, the hydrogen gas, some remaining hydrogen gas will be coming out from this chemical. Okay, such that the efficiency of recovery efficiency will be high. Okay, this is very important. This is very important that okay. Uh, the feed gas. This is the feed gas. This is the feed gas. In feed gas, it is a combination of, or it is a mixture of how many gases? What are the different gases constitute this feed gas? Any one of you? Hello? Hello? In feed gas, what are the different gas?
It will be hydrogen along with carbon dioxide, carbon monoxide,
Yeah. And
methane,
also,
and if it is with the hydrogen is prepared from air, then nitrogen will also be there.
yeah, and also steam like H2
Steam,
H2O
yes. Yeah,
H2O and also methane. Okay,
methane, yeah,
methane,
methane, hydrogen,
methane.
yes.
Higher hydrocarbon. Higher
Correct.
hydrocarbon means more than C2. More than C2 means C3 plus. C3 plus.
Okay.
Okay. Uh, these are the impurities. Okay. If we these are the impurities. If we accept hydrogen. Okay. Except hydrogen, these are the impurities. What is the target? Our target is to separate hydrogen from these impurities. Okay. So what should be the main strategy? If we adsorb, if we adsorb means absorbs. Okay. If we adsorb all the impurities by using different chemicals, by using a series of layer. Okay. If we adsorb different chemical, if we adsorb other gases, and hydrogen will be coming out through the outlet. Okay. And pure hydrogen, you can get the pure hydrogen, or you can separate the pure hydrogen. This is the process. You have to remember which chemicals is useful for which impurities gas adsorption. Okay. If I ask you that, acha, first you see that in the first layer, in the first layer, in the first layer, in the first layer, what type of impurities will be adsorbed? Removal of
H2, HCl and H2, it
ha,
is mentioned.
removal of water. You just remember in the first layer, removal of water will be done by using one chemical. What is that chemical? In the first layer, you can use alumina or silica gel. Already you know the silica gel you use in your laptop bag or high precision instrument, electronic gadget. Okay, this silica gel already you have seen. All of you have seen this silica gel. Alumina is also very hygroscopic material which absorb the water molecules. Okay, and let the surroundings keep dry conditions. Okay, this is the important. Coming to the second layer. Okay, in the second layer, in the second layer, you just see higher hydrocarbon will be adsorbed. Okay, higher hydrocarbon will be adsorbed. In the second layer, higher hydrocarbon. Okay, in the second layer, higher hydrocarbon means silica gel used to remove silica gel. Here also the silica gel can also be used. Okay, can also be used, but activated carbon, but activated carbon is a good for using the higher hydrocarbon. Okay, activated carbon. This activated carbon will also absorb carbon dioxide and CH4 also. Okay, and next step, what is the next step? Next is the carbon dioxide removal step. Okay, next step is the carbon dioxide removal step, and C1 C2, I mean CH4 also will be adsorbed. Okay, so this is the zeolite. Zeolite is a very good chemical. Okay, which can absorb which can absorb carbon dioxide, CH4 and carbon monoxide. Okay, but absorb basically zeolite absorb this nitrogen, carbon monoxide and CH4. Okay, okay. These are the just you remember this name of the chemicals and which chemicals will absorb uh, which gases, you have to remember actually. Okay, what is the characterizations? What should be the major things you have to keep while you will use the different adsorbent? This should be low cost and stable in presence. Stable. It should be stable at high temperature. It should be stable in high pressure. Okay, impurities, and it should be a long life. Okay, these are the process. This is a very simple process. These are the very simple characterizations there should have. And this is all the high purity level you already know, the operating less investment and low operating cost. Okay, I'm not going into details. Okay, next I'm coming to the membrane based separation process. Different membrane material, they are categorized according to the different membrane material, like metallic membrane. Okay, it is made of metal. Metal also can be pure metal or can be alloy. Okay, carbon based membrane, polymeric membrane. Okay, inorganic membrane. Okay, inorganic membrane means oxide, zeolite, glassy and ceramic. These are the inorganic membrane. And polymeric membrane, you have to remember the name of the polymeric membrane, like polysulfone, polyether ether ketone. Okay, and other cellulose acetate. Okay, these are the polymer used for the polymeric membrane. Okay, and what is the principle here in the membrane based separation? In the membrane based separation, in the membrane based separations, there are the different gases. There are the different gases, including hydrogen. In the previous pressure swing absorption process, all other impurities will be absorbed by the chemicals, but here what happen, the membrane will allow only hydrogen to pass through the membrane and other will remain in this side. Okay, such that pure hydrogen can be, you can separate, the pure hydrogen product can be separated. Okay, oh, therefore what should be the membrane characterizations? Like membrane should have high membrane should have high selectivity. What is, do you know, what do you mean by selectivity and permeability? What do you mean by selectivity? Selectivity is a very important property of membrane based separation. Any one of you can?
Selectivity is the specific gas which can pass through the membrane. Selective permeability, we can say.
Exactly. Selectivity means out of the different gases, out of the five gases, four gases, the hydrogen will only pass through the membrane. That property, that membrane will only allow the hydrogen, only select the hydrogen, only he will choose the hydrogen and he will permit for passing the hydrogen from one side to another side. That is called the selectivity. Sometimes what happen, along with the hydrogen, other gases like carbon monoxide, nitrogen, methane will also pass through the membrane. That means if other gases will pass through the membrane, that means this membrane is not high selective membrane. Okay, okay. Is it clear? If along with hydrogen other gas will also pass through the membrane, that means this membrane is not highly selective membrane. Okay. And next is the permeability. Permeability means how fast, how much amount of how much amount of hydrogen gas will be permeated or transport from one side to another side per unit area per unit time. That is the quantitative base property, permeability. How much quantity hydrogen will pass through the membrane? Okay, that is the permeability. Okay, this is the actually two term is very important in membrane research. Okay, and easy synthesis, life should be high, chemically and thermally mechanically stable. These are the simple things. And flux is important. As I am doing some research on membrane, okay, that's why just I am telling you, this is the selectivity, permeability, ion exchange capacity, all the things are important, but here selectivity and permeability and flux is important. Okay, flux is also that is the permeability, kind of qualitative analysis, amount of the gas permeating per unit time per unit area, means that the per unit area or per unit time how much quantity of the hydrogen is transferring from one side to another side, how the hydrogen will how the hydrogen will coming outside, how the hydrogen is permeated from one side to another side. Do you know? Any one of you can answer how the
Through
hydrogen will
diffusion. Through
uh,
diffusion.
yeah, exactly, through the diffusion process. This diffusion process, what is the diffusion process actually? A diffusion process, I told you one example that you will spray one body spray in your room, it will spread throughout the room after few times. This is the diffusion. The diffusion is done, a diffusion happens due to the, in which principle, by which principle uh, diffusion will occur? Any one of you, by which principle? Suppose electricity is flowing, by which principle? Water is flowing, in which principle? Diffusion of your body spray or scent from one side to another side through the air is happening in which principle? Do you know? Diffusion is occurring by the concentration gradient. Okay, water is flowing from one side to another side due to
Head.
uh,
Water head.
water head, but technical term
Hydraulic gradient.
exactly hydraulic gradient. Okay, hydraulic gradient. Hydraulic gradient, and current is flowing from one point to another junction, one junction to another junction,
Potential gradient.
potential gradient. Okay, and diffusion is occurring due to the
Concentration gradient.
concentration gradient. Okay, this is the main working principle of the Fick's law. Okay, this is delta C. This is the delta C concentration gradient. Okay, this is Fick's law. Fick's law tells about the concentration gradient. Okay, Fick's law tells about the concentration gradient and your temperature difference. The heat is flowing from one side to another side, or one junction to hotter side to colder side, cooler side. In which principle? Temperature gradient. Okay, heat is flowing due to the temperature gradient. Current is flowing to the potential gradient. The hydraulic gradient, water is flowing. Okay, this is the things. And for the different case, the different equations is there. Okay, for the heat case, this is the Ka dt by dx. Okay, and here is the for the current v equals to IR. Okay, and hydraulic case, this is the, you know, that the pressure equals to what the pressure equals to pressure difference, height means head difference, and the kinetic difference. Okay, next is the membrane base. Okay, this process, acha, this term is very important. The all the product gas combinations of the different gas mixture, only the hydrogen gas will allow through the membrane, and this hydrogen gas is coming through the concentric tube, and this is called permeate. Permeate means only hydrogen gas is permeated through the membrane. This is the membrane. This is the concentric membrane. Okay, concentric membrane. Concentric membrane means hollow cylinder. There are two hollow cylinder. Okay, two hollow cylinder. Okay, this is the concentric cylinder. This is called, technically called. This is permeated, and another other gases which is not permeated through the membrane, it will remain outside and it will coming out. Okay, as a contaminated gas or other contaminated. Okay, retenate. This term is very important. Retenate. Retenate means that the which is not going through the membrane. Okay, the remaining part is the retenate. Remaining part is the retenate. Okay, this is the feed. Okay, this membrane material can be polymeric membrane material, can be metallic membrane material. Okay, this metallic membrane material, like, what are the different membrane material? Palladium. Palladium is very good membrane material. This is metallic membrane material. What is the working principle of the palladium or metallic membrane material? Okay, uh, this is the this is the important working principle of metallic membrane. Okay, this is also adsorption process. Okay, this is also adsorption process. Suppose this is membrane. This is your membrane. Okay, suppose this is your membrane. Okay, this is your membrane material. Okay, the hydrogen gas will first coming to the palladium surface or metal surface or membrane or metallic membrane, and it will produce H plus and electron. Okay, H plus and electron. This H plus and electron will diffuse. Why diffuse? Because in this side there are hydrogen. In this side, hydrogen molecules concentrations is very high. Hydrogen molecules, hydrogen molecules, hydrogen molecules, hydrogen molecules. But here no hydrogen. Here no hydrogen. That's why it will diffuse through the metallic membrane, and H plus will coming and electron will also diffuse. Okay, and then this H plus and electron will recombine together, and it will form hydrogen, and here the pure hydrogen will, you can get the pure hydrogen or you can separate the pure hydrogen. This is the working principle. First it will absorb, then it will, actually it is technically term is the chemi job. Okay, it will absorb and dissociate, it will dissociate H plus and electron, and then it will diffuse through the material, and then again it will recombine. Okay, this process, this is the metallic membrane process. Okay, and the mechanism of hydrogen permeation via solution diffusion method. Okay, this this process or this process will depend flow of speed, flow of feed feed stream to reach the membrane surface, hydrogen getting chemized on the surface, dissociation of the hydrogen into H plus. These are the process. Okay, and other metallic membrane like platinum also can be used, but platinum and palladium very expensive material. That's why other less expensive membrane material, nickel, vanadium, okay, titanium, zirconium, HF, okay, this can be used. Okay, these are the less expensive material, but the combinations of this material, expensive material and inexpensive material, can also be used as a metallic membrane material. Okay, next is the polymeric membrane. This is very important. Polymeric membrane. Uh, you have to remember these things. There are two type of the polymers. One is the glassy polymer, and next one is the rubbery polymer. Glassy polymer means very hard. Okay, this is not soft. Soft means rubbery polymer. Rubbery is the soft rubber, very elastic rubber. This is the rubbery polymer and glassy polymer. And glassy polymer membrane with high selectivity have lower permeability. Okay, if one membrane is very high selectivity, that means the permeability is very low. Okay, and one with high permeability and lower selectivity. Okay, it is vice versa. Okay, glassy polymer are preferred. Generally, glassy polymer are used, or generally glassy polymer are preferred due to high selectivity. Okay, due to their high selectivity, means that the glassy polymer has high selectivity, but permeability should be less. Permeability will be less, but but selectivity should be important. But selectivity is important because we do not allow, we do not allow other gases with the hydrogen. Okay, because we need hydrogen gas as pure hydrogen gas. Okay, that's why we will prefer glassy polymer over rubbery polymer. Okay, the mechanism of the separation through the polymeric membrane, this is the solution diffusion process, surface diffusion process. Solution diffusion process means this is the chemically occurs. Actually, this is the chemically occurs. Okay, surface diffusion process, this is the concentration gradient, due to the concentration gradient. Chemically occurs means suppose one membrane material, this is non-porous, this is non-porous. How the, this is non-porous, how the H plus ion transport from one side to another side. Okay, this H plus ion will transport chemically, it will go transport from one side to another side in ionic conditions with a hydration radius, with hydration conditions. Okay, H plus ion will, by using the hopping mechanism or cycling or hopping mechanism or vehicular mechanism. Okay, this is the solution diffusion process. A surface diffusion process is a adsorption process, whatever I discussed previously. Okay, Coulson diffusion process, okay, this is the process. Capillary condensation, and the other process, molecular sieving process. The first two process is the important process, and you should understand the solution diffusion process and surface diffusion process. I have already discussed the surface diffusion process in the previous slide, but solution diffusion process is little bit difficult, little is a little complex thing. Okay. Next is the polymeric membrane. Okay. You have to remember the different polymer name of the polymer which is used for separating the hydrogen. Okay. Like polysulfone, polysulfone and polyimide. They are two good polymer for making the membrane material. Okay, for high temperature uses and selectivity, high selectivity. Okay, for high selectivity, high thermal resistance, high mechanical strength, high chemical strength. Okay, this polymer is suitable for separating hydrogen from the other gases for other contamination. uh, Also, the other membrane material, silica membrane material, zeolite membrane material, carbon based material, mixed matrix membrane material. You can see low energy consumption, environmental friendly, easy operations. These are the very simple things. I am not going into details. Next is the carbon dioxide solvent based removal process. A solvent based removal process. This is important. Carbon dioxide will absorb, here absorption process, carbon dioxide will absorb. Okay, carbon dioxide will absorb by the different chemical. Carbon dioxide will be absorbed through the amine, by using amine, carbonate, alkali metal, hydroxide. Okay, physical physical adsorption by using physical absorption by Rectisol process, polyethylene glycol. Okay, these are the chemicals which can absorb the carbon dioxide, and this carbon dioxide will be absorbed and hydrogen, you can get pure hydrogen. Okay, this is the process, this is the absorption process. Okay, and in the previous, during the steam methane reforming process, okay, this compound were used to absorb the carbon dioxide, CaO, N2CO3. Okay, these are the chemicals can be used for the absorbing the carbon dioxide. Next is the cryogenic separation. Cryogenic separation means at lower temperature, just you lowering down the temperature of a gas mixture, you lower down the temperature of the gas mixture. Different gas has the different boiling point. Okay, different boiling point or different boiling point. Due to the different boiling point at different temperature, it will be in the liquefied condition or liquefaction temperature. Okay, different liquefaction temperature. Due to the different liquefaction temperature, at different temperature, different gas molecule will be at liquefied conditions, and you can easily separate the hydrogen. Okay, Next is the water splitting. What are the different process of water splitting? You have to remember: thermolysis, thermochemical cycle, photolysis, electrolysis, photobiological, photoelectrochemical. What is thermolysis process? Anyone of you can say? Anyone of you answer?
Splitting of water with the help of heat,
Yes. Next,
temperature.
next is a thermochemical cycle means
With the help of temperature and chemical.
with the help of the heat means
Heat
temperature
and chemical.
as well as some chemicals. Okay. Next is the photolysis.
With the help of light.
Yeah, with the help of light. Next is the electrolysis with the help of the electricity.
Electricity.
Photobiology, photobiological means
With light and some biology, means biological way.
ha like the tree in which process oxygen will generated. Okay. uh, this sort of process. Okay, biological process. And photoelectrochemical, light, electricity,
Light,
and
electricity, and chemical.
also chemical. This is the hybrid process. Thermolysis process, you have to remember the temperature. The What is the temperature for dissociation, dissociations of water? What is the temperature of the dissociation of the water? Suppose you are taking one glass of water. At what temperature this glass of water will be dissociated? Will dissociated into its constituent hydrogen and oxygen. At what temperature? 4500 Kelvin. 4500 Kelvin. Okay. This is the complete dissociation. At 2500 Kelvin, only 3%, and around 3000 Kelvin, less than 50% water can be dissociation. Dissociations will occur. Okay. Can you do you see that what higher amount of the heat or higher amount of the temperature is needed for dissociating this hydrogen and for dissociating the water into its constituent element oxygen and hydrogen. So this process is very difficult to establish. Okay, that's why you have to go, or that's why you have to move the for the other process, for that, such that the temperature can be reduced. Okay. Next is the thermochemical water splitting process. That's why thermochemical water splitting process comes. Okay, that means by the using of the chemical and heat. Okay, we will split the water. Okay, the temperature is range is the 500 to 3000 Kelvin. Okay, how the thermochemical water splitting process is done, we will show. This is the process, metal oxide based thermochemical process. Means here the input is the heat energy. Input is heat energy. Input is heat energy as well as chemicals like metal oxide. Okay, some metal oxide is used. Some metal oxide, MOX, metal oxide is used. Okay, by using this heat and metal oxide, water can be split into its hydrogen and oxygen. Okay, how the process is occurring? First, first MOX, this MOX, this MOX, by using the heat energy, it will reduced. Reduced means, okay, reduced means that the oxygen number, oxygen valency, oxygen is, it is number is getting less. Okay, that the MOX minus Y, that is the Y by 2 oxygen, it is producing oxygen. This MOX 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 minus Y, it will participate here in this process. It will react with the water molecules. It will go for the hydrolysis reaction and it will produce MOX. Again, it will regenerate this MOX for the starting reactions. This MOX and hydrogen gas. Okay. By using the second step, we are getting the hydrogen. Okay. By using the second step, we are getting hydrogen. In the first step, we are getting oxygen. Okay. Actually, what is happening here? This is the reduction process. This is the reductions of the metal oxide, and next is the reformations of the or regenerations of the metal oxide process. Okay, just you have to remember these things. Okay, this metal oxide MOX, different metal oxide can be used. Fe3O4. Okay, Fe3O4 can be used. How the Fe3O4 can be reduced? The Fe3O4 will reduce to FeO and oxygen at around 1873 Kelvin, and again this FeO plus water, it is the regeneration process of Fe3O4. It will produce Fe3O4 and hydrogen. Okay, this is the step. And other energy and oxide loss, to replace this Fe by nickel, cobalt, molybdenum, etc. can also be used. Nickel oxide, molybdenum oxide, Mn oxide can also be used. Okay, and this is the ZNO. Same reactions. You can one reactions, if you understand, then these reactions also easily understandable. Next is the, this was the two-step process. Next is the three-step process. Why we are going for three-step process? Any one of you can answer? Why here we are modifying this two-step process into three-step process?
To reduce the temperature.
Exactly. To reduce the operating temperature means that the we always want for water splitting at lower temperature. Okay. Earlier two-step process was at 1825 Kelvin, around 1900 Kelvin, but here in the three-step process the temperature was reduced, or temperature at around 800 degrees centigrade, at 800 degrees centigrade. Okay, at 800 degrees centigrade. Why we are reducing the temperature? Because for water splitting we do not need to utilize high amount of the heat or high amount of the temperature. Okay, we always want at low temperature water dissociations. Okay, this, if we establish this low temperature water dissociation, this will be a very noble work or noble research. Okay, low temperature water dissociations. Okay, we also can dissociate water at low temperature water dissociation through electrolysis. Okay, but in this process, if you discover or if you invented something, some by using some reaction, it will be great work. Okay, or it will be great research. Three-step reaction process. What is the three-step reaction process? Here iodine is used. Here iodine is used, and SO2, sulfur dioxide gas is used. Iodine and sulfur dioxide and water. Okay. First step is the at 120 degree centigrade, iodine, sulfur dioxide and water will reacted, and this is produced, and this produces Hi and H2SO4. Okay, and this H2SO4, for this reaction above 800 degree centigrade or around 800 degree centigrade, it is dissociated, and it produces dissociated with producing H2O and SO2 and oxygen gas. Okay, and this HI, the remaining HI will produces iodine and hydrogen gas. This is the hydrogen evaluation reaction. Okay, and this iodine is used with the SO2 gas for making H2SO4. This H2SO4 will generate oxygen. Okay, and here this HI will produces hydrogen. Okay, you have to remember that these three-step reactions will occur at around 900 degrees centigrade or 800 degrees centigrade or above 800 degrees centigrade. But we want to reduce this temperature further. How we will reduce? Four-step thermochemical cycle. Okay, this four-step thermochemical cycle, you can reduce the temperature in this process. Chlorine and iron, by using the chlorine and iron, you can reduce the temperature up to 650 degrees centigrade. Okay, but using the copper and chlorine, the temperature can reduce up to 550 degrees centigrade. Okay, these are the four-step reaction process. First, this is a very simple process, reaction process. uh, First is the chlorination steps. Here is the Fe3O4 plus HCl. It will react and it will produce FeCl3 and FeCl2. Okay, and this FeCl2 and FeCl3 will one FeCl2 will go for will be will present for the hydrolysis steps, and FeCl3 will be the decomposition step. Okay, and for the decomposition step, chlorine will produce, and this chlorine and hydrogen will produce as HCl. Okay, these HCls again will used for the chlorination steps and hydrolysis steps. Here hydrogen will produces. Okay, the temperature at around 650 degrees centigrade. Okay, and when we will use the copper and chlorine, you can reduce the temperature below 550 degrees centigrade. Next one is the hybrid thermochemical cycle. This is the hybrid chemical cycle, means that the here heat energy will used and also electrical energy will also be used in this process. This process is the same process as the first process, H2SO4 dissociation, H2S and water and oxygen. Okay, and this SO2 plus H2O, it will again formations of the H2SO4 and hydrogen. Okay, when we will apply some sort of electricity or some sort of voltage difference, it will at 100 degrees centigrade hydrogen will produces. Okay, this is the hybrid thermochemical process in which temperature as well as electricity can coupled for producing for generations of the hydrogen. This is also a hybrid Cu and Cl cycle, and there is a reaction shown here, and you can see the reaction. And UT3 reactions, you can go through the reaction. Here is the calcium and calcium bromine is used. Here the temperature at around 1000 degrees centigrade. 1000 degrees centigrade. Okay. This reaction, these steps was discovered by the invented by the University of the Tokyo. Next is the coming to the electrolysis of water. Okay, why electrolysis of the acha? Before coming to the electrolysis of the water, there are very less percentage of the hydrogen is produced through the electrolysis of the water. How much percentage of the water is hydrogen is produced through the electrolysis? Anyone can you? Anyone can answer? 0.03% of hydrogen is produced by the electrolysis process. Okay, Okay. This is the basic working principle of the electrolysis. Working principle of the electrolysis. For acid electrolyte in the cathode, acid electrolyte means here the acid electrolyte means the H plus, the availability of the H plus is high. Okay. In the cathode, the reactions is very important. In the cathode H plus, it will absorb, it will the two electron will get combined with the H plus and it will form the hydrogen gas. Okay. And in the anode, water will split oxygen and H plus and two electron. Okay. For the alkaline electrolyte, the cathode, water will react with the two electron, it will produce as hydrogen and OH minus ion. Okay. In anode, this OH minus ion will attract it to the anode side because it is positive charge, it is negative charge. Okay. And this will form the oxygen. Okay. This is the basic of the electrolysis process. This is important. Suppose you want to going for water electrolysis. Water is in liquid condition. Water is liquid condition. That means you have to spend some heat energy. You have to spend some heat energy, and also you have to spend some electrical energy. Okay. Heat energy by means of work done you can also spend. Okay. Uh, this is the delta H. Delta H is the total enthalpy. Total enthalpy means that the total heat energy required for splitting the one mole of water. Okay. This 285.84 kilojoule heat is required to split 1 mole of liquid water. Okay. And gives free energy delta G is delta H minus T del S. Okay. This is, you have to remember, 237.22. Actually, uh, this value is little bit of confusing value. You have to remember T del S value, T del S, T del S value is equals to 48.70 kilojoule, okay, per mole. Okay. Then if you T del S, just you delta G value will come this amount. Okay. Okay. Are you getting me? Okay. If you split water from the vapor state, this delta H value will be lower. It will 241.8 kilojoule per mole. Okay. Because vapor state already at high energy state. Okay. This is the graph showing that the energy consumptions and temperature. Okay. The delta H value is constant throughout the temperature, all temperature. Okay. This is the vaporizations of the water zone. Okay. This is the vaporization of the water zone. That's why the shift is here. Okay. and delta Z is little lower, little lowering, and T del S will be little upward direction. It is, the value is little higher when the temperature will rise. Okay. Uh, this process, this is the simple process. This some sort of calculations or some sort of derivations is here for formulating the voltage. Okay. Mm, two things you have to remember, that the thermodynamics voltage, that is the E naught equilibrium voltage is water splitting. Minimum water dissociation voltage, what is the minimum water dissociation voltage? Reversible condition, at reversible condition 1.23 volt. Okay. And another one is the thermoneutral voltage. This thermoneutral voltage is 1.48 volt. You have to remember. Okay. 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 These things, some you have to understand these things. What is happening? The boundary at the electrode surface, actually at the electrode surface, there the boundary layer separation, boundary layer or double layer capacitance is occurring. Double layer capacitance is forming. Suppose this is negative electrode or cathode electrode. Cathode means rich of electron. This is means the negative, minus V. Okay. This is the electrolyte. Here the interface is the interface means that this is the solid and this is the liquid. In between, it is called interface. The positive ion will attract to the electrode surface, and here compact layer will formed, and just beyond the compact layer, the diffusion layer will be there. In the diffusion layer, the ion will scattered. The ion is scattered conditions. The ion is scattered conditions. This is called diffusion layer, and this is the called the compact layer. The electrode voltage is phi E electrode voltage, electrode surface voltage, and solutions voltage is phi S. Okay, how the variations is happening? How the variations is here? If first the phi E to up to the compact layer, this is the linear variation, then the exponential variation. You have to remember these things. Okay. Electrode phase, physically mechanically stable. Electro, these are thing. Solvent, what is the most compatible or suitable solvent may be used in the electrolysis process? Water is the most promising or suitable solvent that can easily abundant in the universe. Okay, this is low cost and stable. Okay. Okay. And this has a polar, this is the polar solvent. Actually, water is the polar property. That's why a dipole moment is there. That's why H plus and OH minus will and that's why it is get attracted to the electrode, and it can it can break into H plus and OH minus. Okay, self ionization of the water. Self ionization of the water is the small, but when it will come to the contact of the electrode, the the splitting will occur. Okay. These are different separator. Porous separator has the diameter around 0.5 to 12 millimeter. Okay. Porous separator, if we use the porous separator in the electrolyte, the anode electrolyte and cathode electrolyte will be mixed easily because it will mix through the porous separator. But microporous separator, only the ions will transport from one side to another side. But ion exchange membrane, here ion exchange membrane will not allow to mix the anolyte to the catholyte or catholyte to anolyte. Only the ion will transport from one side to another side. Okay. Sometimes this allow selectively. This is the passage size is the 10 to the power minus 8 to 10 to the power minus 9 pore diameter, but sometimes it is called non-porous separator, means that there is no porosity, non-porous material, non-porous separator. Okay. The requirement is the high selectivity, high chemical stability, high mechanical stability, high ionic conductivity. One thing is important, this separator should have high ionic conductivity but less electronic conductivity. Okay. The ion will passes through the membrane easily, but electron should not passes through the membrane. If the electron will pass, or if this membrane or separator is highly electronic conductivity, what will happen? Anyone of you can answer this?
There may be reversal of current.
uh, no. Suppose I am drawing these
No
things.
flow, no current flow.
No, just you have to understand these things because okay, just I am drawing these things. What is happening? Suppose suppose this is your cell. Okay. In between your membrane is there. In between your membrane is there. This is your membrane. Okay. And this is connected through the electricity. Suppose this is one plate. This is positive electrode, and this is negative electrode. This is negative electrode. Okay. What is, suppose a solvent is, or electrolyte is water. Okay. Water. Okay. Water. This is membrane. Okay. Only the ion will pass through the membrane. Here only the ion, suppose in the anodic, suppose this is the anode reaction. Okay. H2 H2O, okay, will split. This is the H plus, which this H plus will attracted, this H plus ion will attracted to the negative electrode H plus, and this H plus will receive 2 electron and it will produces H, and 2H will form the hydrogen gas and hydrogen gas will be evolved. Okay, okay, and this is the basic working principle. Okay, here what happened, here I am allowing this membrane, I am allowing only ions to the membrane and electron through the external circuit. If the this is the electrically conductive, then what will happen, then it will actually, it will not complete the external circuit. The electron will also flow through this solution, through this membrane. Okay, okay, the short circuit will be there. Okay, and electron will not flow through the external circuit. The main motto is that the electrical circuit will be outside external electrical circuit, electron will flow through the external circuit, and only ion will flow through the cell cell resistance or cell assemble. Okay, this is the working principle actually. Okay, we have to allow the electron through the external circuit and ion through the solutions or through the electrochemical cell. Okay, this is the things. Next I am coming to the coming for some assignment MCQ. Okay, huh. First question, the purifications of product stream obtained from a hydrocarbon based hydrogen producing productions method using carbon dioxide solvent based removal method can be categorized as dash adsorption based purifications, membrane based purifications, absorption based separations, cryogenic separation.
Absorption based separation.
Why it is absorption based separations?
It is absorbing CO2.
Yeah, exactly. Here using carbon dioxide solvent based removal method. A solvent based removal method means solvent. So some solvent is used for absorbing this carbon dioxide. Okay, that's why it is absorption based separations. Okay, so our answer is C is correct. Okay. Next, select the correct order of step in SMR with pressure swing adsorption method. What is the correct steps in the pressure swing adsorption method?
A, SMR,
Uh,
high
uh,
temperature water gas shift, then
huh,
PSA.
then PSA. If we use the SMR, high temperature gas shift reaction, low temperature gas shift reaction, and PSA, this is this is correct or not?
No, in that case, I think when we take low temperature water gas shift reaction,
Hmm.
uh, we need to include carbon dioxide removal also before PSA, I think.
Actually, what happened? If we why we are using a PSA, because carbon dioxide will absorb, or carbon dioxide the main motto is the to separating carbon dioxide from hydrogen. Okay, if we use high temperature water gas shift reaction, low temperature water gas shift reaction, then the quantity of the carbon dioxide or carbon monoxide, these things will also reduced. Okay, so directly just you use the So SMR,
Yeah.
high temperature gas shift reactions, and pressure swing adsorption process. Adsorption process means that the carbon dioxide gas will be adsorbed. Simple things. Okay. And this process is the steps is the wrong steps actually. Okay. Low temperature before it should be high temperature. Okay. These unnecessary large number of the steps no needed. Okay. The methanetions. Okay. Methanation process. This is also wrong. This is the SMR reaction. This should be SMR reaction. High temperature low. Lastly, SMR reactions is not. Methanation reactions will become. That's why our option A is correct. Question number 3. What is the purpose of the pressure equalization steps in PSA? Pressure equalization step in PSA.
To
How the
recover
pressure?
additional amount of hydrogen.
How the pressure? Do you remember how the pressure equalization step in PSA I discussed? Do you remember? Anyone of you? How the setup is there? This is high temperature. Sorry. This is high pressure. This is high pressure, and this is the low pressure. The setup is like this. This is the feed, and it is counter direction, and the hydrogen gas is fed. The hydrogen gas, lower amount of the hydrogen gas is fed. Okay, and in this way, the if the some hydrogen is absorbed, some hydrogen was remained, some hydrogen, if the some hydrogen interrupt to the chemical, this hydrogen will also coming outside, or we can recover this hydrogen. Okay, that's why the correct option will be to recover additional amount of the hydrogen. The amount of the question number 4, the amount of gas permeating per unit area per unit time is expressed using which laws? The amount of the gas permeating per unit.
Fix first law.
Ha, this is the fixed first law. What is Darcy law? Do you know? Any one of you can answer these things. This is used for measuring the friction, friction measurement in flow through pipe. This is flow through pipe. When the water is when water is flowing through the pipe. Okay, when water is flowing through the pipe, the velocity will reduce. Okay, the velocity will reduce. Why the velocity will reduce? Because pipe wall friction is there. Okay, this friction velocity, or at the inlet velocity is v1, outlet velocity is v2. What is the outlet velocity? This outlet velocity is measured by the Darcy law. Okay, you know the first law of thermodynamics and Newton law of viscosity. The correct option is the B. B is our correct option here. Okay. Question number 5. Why it is difficult to separate hydrogen from hydrogen and carbon dioxide mixture? Why it is difficult? Carbon dioxide and hydrogen is very difficult actually. Carbon monoxide is good. Okay. Carbon monoxide we can easily separate by using uh, by using by applying or by implementing water gas shift reaction. But in question, Why it is difficult to separate hydrogen from hydrogen and carbon dioxide mixture? There should be some similarities of the hydrogen and carbon dioxide. Okay.
Due to low
So,
difference,
ha,
Answer A.
answer,
lower difference in permeability coefficient.
answer A. Because low difference in permeability coefficient means that this is the suppose I am using one membrane. Okay. What is the permeability coefficient of the hydrogen gas? The same sort of permeability coefficient of the carbon dioxide is also. Okay, permeability coefficient. That's why the lower difference, it's not larger gap. Okay, lower difference means suppose this value is 1, this value is 1.1. A very less difference in the permeability coefficient. This permeability coefficient is very nearer of hydrogen and carbon dioxide. That's why it is difficult. Okay. Question number 6. If the energy is provided by the light alone in the water splitting, then the process is known as
Photolysis.
photolysis. Okay. Light means photolysis. Okay. This is simple. Complete dissociations of water into hydrogen and oxygen occur at a temperature of very
4500 Kelvin.
very high temperature 4500 Kelvin. Question number 8. The Gibbs free energy change for the dissociations of the liquid water into hydrogen and oxygen is dash kilojoule per mole. You have to calculate actually. It was confusing in lecture, but I am telling you what is happening actually. Suppose suppose one electrolysis suppose one electrolysis, this is suppose this is just it is very important, you just remember. Suppose this is water. Okay, suppose this is water, this is positive and this is negative, minus V. Okay, for splitting water what is required? For water splitting what is required?
External source of energy.
External source of energy in terms of heat energy. Okay, it may be in terms of heat energy, it may be in terms of electrical energy ELE. Basically these two type of energy is required to split the water. Okay, ultimately we need energy, some sort of energy. Suppose we need total delta delta H amount of the heat we sorry delta H amount of the energy we need to split the water. Okay, how the delta H is coming, that is the different calculation, but that is the different calculation, but delta H value, you know that uh, delta H value is, you know what is delta H at standard condition,
285.84.
285 285.84 kilojoule per mole. What is delta is actually total energy required. Okay, total energy required. It include heat energy as well as electrical energy. Okay, so formula is, what is the formula actually? What is the formula? Delta H equals to delta H equals to delta H equals to directly I am writing delta H equals to delta G plus T del S. What this significance? Delta H equals to total energy. Obviously, the total energy means delta G is the electrical energy. This is the electrical energy. Okay, this is the electrical energy, and this is the heat energy. Okay, this is the heat energy. Understand? You know the delta H. You have to calculate delta G. And what is the T del S? The T del S is the electrical energy. The T del S value is the 48.70, 48.70, 48.70 kilojoule per mole. If we minus this 48.70 from 285.84, it will come your value 237.22. Okay, this is the Gibbs free energy. Next, select the appropriate reaction that occurs at the cathode in water electrolysis, with alkaline electrolyte. What happen with alkaline electrolyte? The OH minus will get attracted by the
Hello.
hello.
If we subtract the figures which you have given,
Hmm.
so it comes to 237.14,
Okay, okay. It's no, it's a minor
close to somewhat.
changes. Okay,
Yeah.
okay.
Okay.
It's no problem. In the alkaline water electrolyzer, the working principle of the alkaline water electrolyzer, mm, we will discuss actually in the next classes how the alkaline water electrolyzer, PEM water electrolyzer is different. First, the alkaline water electrolyzer is the most suitable till now commercially it is using in the industry, but PEM water electrolyzer has some 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 level of PEM water electrolysis is also commercialized, but anion exchange membrane water electrolyzer still not commercially viable. Okay, but in alkaline water electrolyzer, what happen? OH minus will get attracted by the anode electrode. Anode electrode means your positive electrode. Okay, OH minus will get attracted. Okay, OH minus electrode, OH will attracted anode. Okay, what is the reaction here at cathode? In cathode what will happen? Just read the reaction. H plus 2H plus 2 electron, it will produces hydrogen in cathode. Okay, you know, in electrolysis, at anode means positive, oxygen will produces. At cathode, hydrogen will produces. So what will be your correct answer?
A.
How A will correct? With alkaline electrolytes.
See, OH ion will be at anode, as you said. The
uh,
electron will pass through cathode and combine with 2H to form H2.
in here with alkaline electrolyte, no, alkaline electrolyte means it is full of alkaline. The electrolyte cell
Okay.
is, this is the full of electrolyte. Okay, suppose this is positive, and suppose this is negative. This is negative. And the water plus electron, two electron will react together, and cathode hydrogen will produces, and OH minus will produces. This OH minus will get attracted by the H plus anode, positive V. Okay, in alkaline electrolyte. Okay. Okay. Next, question number 10. Separation through a non-porous membrane. Separation through a non-porous membrane.
Solution diffusion.
Solution.
Solution diffusion. And solution diffusion, I told you that there is the difference in solution diffusion and surface diffusion. Surface diffusions, you know that how the surface diffusion is. Surface diffusion, suppose this is your membrane material. Suppose this is your membrane material. The adsorbed hydrogen is coming, and it is adsorbed on the upper layer of the surface. It is called chemisorb, means that the H plus, it will form H plus and electron. H plus and electron. This H plus and electron will diffuse through the membrane material through the porous channel. Okay, this is the porous channel, and this hydrogen and electron will again recombine together, and it will form the hydrogen. This is the surface diffusion process. And solution diffusion process, what happened? Solution diffusion process, in membrane there is there is no pores, how the H plus will go from one side to another side. I told you the process. It was vehicular mechanism, and another one is the hopping mechanism. Actually, what happened in the membrane, there is the fixed charge. Suppose you want to pass H plus ion from one side to another side, so here negative fixed charge is attached. Negative fixed charge will be attached. This negative fixed charge will attracted this H plus ion, and series of negative charge will be there, as it is as it is in molecular level. This H plus will hop from one fixed charge negative charge to next negative charge, and in such a way the H plus ion will come or migrate from one side to another side. Okay, and this is very also, it is very critical process, or difficult process, or very not discovered till now. Clearly, mechanism is not clearly clear till now. And this H plus is surrounded by hydrogen molecule. This is the hydration hydrated condition. The ion will pass through, ion will hop with the hydration condition, because the dry conditions membrane cannot allow H plus from one side to another side. This is important. A hydration conditions mean H plus ion and surrounded by the H2O molecule. I mean H2O molecules. I mean this is the hydronium ion condition. H3 H3O plus condition. The ion will transport from one side to another side. Anyway, this is at research level. You can do research on this topic. So this is the solution diffusion process. That's why solution diffusion. Solution means hydrated condition. Solution level, solution diffusion. Okay, this is the process. So our answer is the A. Okay, this is the total week 4 series. Hello. Anyone of you have any question regarding today's lecture? Uh, okay, we'll see in the next week. Uh,
Okay.
okay, okay, you can leave.
Thank you.
Okay, thank you, thank you.
Thank you. I'm listening.